Hi everyone. The topic for this video is RC time constant in LTspice program. Here we'll explore the RC time constant using LTspice program. The RC constant is denoted by tau, described how quickly a capacitor charges or discharges in the RC circuit. Mathematically, this tau equals R times C. Let's build a circuit in LTspice. Okay, this is LTspice as you see, and we're gonna open a new window. So in this new window, we will start draw circuit. First, I'm gonna bring out voltage and this. So let me see, try to make it smaller. Okay, and then after that, I'm gonna bring it resistor and then capacitor. Then I'm gonna bring out the ground. Okay, so I'll line this one. So why it will. You'll see why. After that, like I connect. Okay, instead of this one, we don't need this one, so I'm gonna eliminate. Okay. Now, after that, after you put component, then I'm going to connect wires. Okay, starting from here, go all the way in, and let's make and going down, connected. Then all the program will fix and connect all together. Okay, then I like to add input, checking the input, so voltage input. Okay, and then after that, like input port type, right? So put the port type here, over here. I'm gonna put it over there. Okay, and then after that, I'm gonna put voltage output. So it's gonna be V out, and port type is output, right? Okay, so okay. Now I'm gonna put over your port type here, and then I connect these two port to the here, probably good. And here, the output, I'm going to connect there, so it's good. So I completed all the circuits. Then after that, like I'm going to put some value for the resistor here. I'm going to put some second button of mouse, and then you'll see I'm going to put 10 ohms there. Okay, and then here, I'm going to put here, second button. I'm going to put, I see 1 microfarad, okay? Okay, so then, okay, so you see, resistor 110 ohms, capacitor 1 microfarad. And then here, voltage, I'm gonna go to voltage setup. So what I wanna do is a voltage, it's gonna be 10 volt. After that, like just 10 volt, from 0 to 10 volt. And the advanced go there using pulse. So mark a pulse, then you'll see automatically come out there. So initially, what you're gonna do is you're gonna go from 0 to 10 volt. So from 0, starting from 0 and 10 volt, the last is 0.5 millisecond. Okay, 0.5 millisecond. And then now T rising time is, I put like 0.5 nanosecond. You can put one nanosecond. And we're going to put like a 0.5 nanosecond rising and fall. Okay, so now stay on after a drop from 10 to bottom. You see now another, we need a 0.5 millisecond. Stay there as a 0. And in total, the period is going to be 1 millisecond, right? So we set up here, then we see this display. Then after that, like we move, I'm going to move this one to clicking this move, and you click, and it just move to, let me move to here. Okay. Then I need like a duration time, which is you can go to here configuration analysis. Then here I can put I put like a 10 millisecond. Okay, then it's just continuous 10 millisecond. It stay there. Okay, so now our circuit is done. So what I would like to do is I like to run. Okay. See, now it's around here, and then what I'm gonna do, I'm gonna try to arrange it. Okay, so more likely here to reduce to circuit and this vertical line here. Okay, so from there, I like to add output from voltage in. So I'm gonna add plot setting and add plot planes. Okay, this is one. In the second plane, I will use V output. And also I'd like to add more the output. Third plane, I'd like to put some difference between V in and out, which is voltage of a resistor R1. And I'm gonna add one more. So that is gonna current through this resistor. And all this combined plot, I will put the last one, which is I put on the bottom. Okay, so now here you already put like a 5 output this plot space. So here what I like to do is, let me see, put this move here. Now here I just click here, and then after that, like you can go to second button, okay, and then add a trace. And you'll see already like it runs and it start to show this. So I'm going to put the voltage in and then okay. See, now it displays from about 0 to 10 volt, just one cycle. So it's going to be 10 cycles because each period is 1 millisecond. So it's in 10 milliseconds, there will be 10 cycles. It's 10 periods. Next port, I like to add that's a V. So that's a V in. And then the next one is add a trace. And I'm going to add it V out. Okay. Then you see the V out a little bit like a angled, but it's sharply up because of the R value is 10 small. So that's why charging fast. Next one, I would like to add trace. This time I'm gonna voltage this one minus voltage out. Okay, so this will show the difference between these 2 volts. So what I like to do, I like to add this here like a voltage cross resistor, which is R1. Okay, voltage R1 and equals. So okay, then I'm going to move it to here. Okay, so it's ready. Now, what I like to do, I like to change color. So it's going to be, put the red color. Okay, that was back to change. Now, the last one is going to be current. I'm going to add a trace again. It's going to be current across the resistor. So after that, like you put okay, then you see the current. If you like have some more different color, then you can go second button and then let me put some pink value. Okay, so okay. Okay, so now this all graph is done. As you see, the charging speed is fast because tau, which is time constant, is small. Okay, now, and after that, the last one, I like to add all, this is one place, everything. So that means like a VIN, right? And then V output. And then after that, like a V in, and then you go there, you just put the operation and V out. Okay, so just you can go, okay, but just eliminate the blank. And then after that, like here, the last one, current R1. Okay, so it's all one place. Let's go. Okay, that's good. So now from there, if you want to see any specific output, then you can click the button, then you will see a green color standing out, and then be out, and then be input. So this one is trace button, and then be, you see all these different output. So now after that, like you see all the graphics on the right side, I'm gonna make this one some this side. I'm gonna make put some adjustment like here. Okay, so now this is the resistor 10 ohms and the capacitor 1 microfarad. Okay, now with the same input pulse, let me change to register value 60. So I will change to 60. And okay. And then after that, like you just run simulate, and you see all graph has been changed. After all, like as you can see, the charging speed is now slower than the last one. See, it just angled a little. So you can see the slope. So this is how you can see the time constant thing. It's just the preserve, like the big, larger number of constant speed, constant, then the speed is slow. Okay, so next, I'm going to change to, let's see, we're going to go more, see, and then 1,000. Okay, so 1,000, right? And then you say run. Okay, you see now it's slow. So that's why like even before it discharge it, you just keep charging it fully. So that's why the slow is slowly increasing. Okay, next when I move to this one to 10,000, it's going to happen. It's going to shift 10,000, 10,000. Then you see, okay. Then when you run this one, you see all this one. The output is just kind of little slow to pace, but I see actually this happened because it's just charging before it discharge fully or just ongoing. Next. Okay, so now let me change this one to pulse, okay? Let me change a different pulse, different input pulse. So what I'm gonna do, I'm going to change to from -5 to 5, -5 to 5, and this one, let's see, -5 to 5, and then delay is going to be 0, right? 0, and after that, everything's the same, right? So next. So I'm going to put OK, and then we're going to run this one. You see now, you see the input pulse is from -5 through 5, right? -5 through 5, and you just keep running uh, pulse signal from -5 to 5. Then, because of 10,000, let me change to this one to 5. So we're starting from 10, right? It's 10 ohms. Then it's going to be sharper. Okay, now we're going to run. You can see it's just really like the second output is almost like similar as the input signal. And then I changed to 10 to almost 60. Then it will be slower. Okay. Okay, so then after that I run it, then you see it's slower, charging time is slow. Now, as you increase the value of a resistor, 1,000, and then you run, obviously you can see now like we just the same behavior as before. And then even like you increase this one to 10,000. Okay. And you'll see this one. You run this one, then obviously you can see all the difference. Now, this time that if you go more specific signal, then instead of 10 milli for transition time, then we're gonna change to maybe 2 millisecond. Okay, let me change to 2 millisecond. Then okay, 2 millisecond. Instead of 2 milliseconds, so let me, because I input 2 millisecond, okay. See, now you see 2 millisecond. Then when I run, let me change the resistor to 10. Resistor to 10. Okay. And okay. So now obviously you can see here, this is 10. And you can tell like 10. And you see run, you see 10 ohm is kind of still very sharp. The slope is sharp. Okay, now if I move this 10 to 60, then you will get, okay, and then you run. Then you see now, you can see the slope is changing, but slow, not like sharp as before. So as a result, you can see when you move to higher, like 60 to 1,000. Okay, then when you go run it, then you see now really slow, right? So this will tell you that if we increase the resistor R value or capacitor C, the charging curve stretches out. If we decrease the capacitor charge more quickly, right? If we go numbers going down, charge speed just speed down. So this proves the relations between relationship equals to the tau equals to the R times C holds true. So thank you for watching. And then finally, the background originally, like the changing the way the background is, you go to tool and go to setting. And then you see like a schematic and the waveform. So if I put schematic, then see the pen stretch is 5. If I put 1 schematic, then you see it's going to be, you notice the line is thinner. So I put this one, make it 5, then you see thicker, right? Okay. And then now for the waveform, okay, now for the data trace, this is 5. So if you put this trace it to down, then it becomes thin. And then if we more, I make it thick so that it's more visible. Now for color scheme, so you click the color scheme, you see there. So you go to trace. You see here when you look at here, you can just click and see background. You click the trace, you will have the trace. So you can use like you open up here in the background. So I put 255, everything full 255, 255. Usually the factory setting is like dark, this is 000, make it dark. So it's kind of the screen make it black out, like sometimes difficult to read. Okay, so I just set it up, white background. Okay, so like this way, apply. Okay, so that's why white. Okay, so if I change to this one, you see the background is a dark, right? Start apply, then dark. Okay, so instead of dark, I just selected this one, which is actually required to do. So I just put OK. So this is what we got. Okay, thank you for watching the demonstration of RC time constant in LTspice.